Hey, I was checking one of your things recently and I noticed you were trying to convert something from ppm to percentage. And I noticed something and I just thought you might want to know what I noticed. Um, I'll just get right to it. Okay, you got an answer in ppm. I don't remember exactly what it was, but let's pretend it was 6 ppm. I had checked all your calculations up to that point and it was perfect. And I agreed with this answer. And then your spec um, your specifications were in percent, so you knew that you needed to convert this ppm to percent. Great. So this is what you wrote. You wrote all this, which is good. Except, I don't agree with this at all. I agree with this, and I agree that 6 ppm equals this, but this is there's something wrong here. I see what you're trying to do. You're trying to use the substitution method. You're trying to get rid of this ppm and substitute it with this, but let me explain what I see wrong with it. Okay, I see two things wrong here. I see that, first of all, you're saying 6 ppm equals 6 times this. Well, this is 100 ppm. You're saying 6 ppm equals 6 times 100 ppm. See, this is 100 over a million. That is 100 per million. Remember the line in a fraction, you can always use the word per. So this is 100 per million. So something's wrong here. Also, my other question is, how did you get the percentage sign in your final answer? I mean, I see it at the very end, but how did you get that in there? Where did it come from? There's a simple way to fix this. You just forgot your percent symbol. See, this is 1 ppm. See, this is 100%. 100% is 1. So this is essentially 1 per a million. So this is correct. This does equal. And the bonus, which is excellent, is that you introduce this percent symbol into your equation. The percent symbol is a constant number. It equals 1 over 100. We all know that. But it's a dimensionless unit, and it has to be, you have to account for it. And that's how you do it. To convert any number into a percentage, you have to multiply by 100%. Not 100, 100%. And you can see from my calculations here what I'm doing. I've got 1 ppm equals 1 ppm times 100%. I've just multiplied it times 1, so that's perfectly legal in math. So now I'm converting ppm to 1 over a million. Now I'm rewriting it so you can see it all as one fraction. I multiplied 1 over a million times 100%. Now that's what you could have substituted into, that's what I was showing you before. You could substitute 100% divided by a million. But we can take this a little bit further. We can cancel out 2 of these zeros in the numerator with 2 of these zeros in the denominator. And now you have 1/10,000th of a percent. See? 1% over 10,000 is 1/10,000th of a percent. So I guess I just wanted to tell you about that the percent symbol is a constant number, just 1 over 100. Of course, that's not an issue here. I think you understand that. But it's a dimensionless unit that you have to account for. And when you substitute something for ppm, you really have to write something that actually equals ppm, not something. You don't want to substitute something that equals 100 ppm, because then it's not correct. This is something else I wanted to mention, and I have not seen you do this, but I have seen other people do this, so I thought, what the heck, I might as well mention it since I'm making this little video. So if you're going from a number to percent, you multiply times 100%. If you need to go from a percent back to a number, you divide by 100%. Kind of makes common sense, right? They're inverse functions. And I mention that because this is something I see from time to time too. And I don't know if you do this, but if you don't do this, then just ignore this. But this is just kind of a bonus for this video. let's say you pull up a C of A for compound X and its purity on the C of A is 98%, but you need to use this in a calculation. You need to divide by 100%. See, 98% divided by 100%, your percent symbols cancel. You know, they're dimensionless units, so we can cancel them. This is 98 times the percent symbol. This is 100 times the percent symbol, so we can cancel them. And we have 98 over 100, and that equals 0.98. That's good math. That's what you want to do. Now, some people, this blows their mind. They don't understand this, but hey, they understand grams. So if you understand purity in terms of grams, then write it that way. Right? Hey, there's 98 grams of compound X per, remember, per 100 grams of material. And then your grams cancel, and then you still come out with 0.98. Please do not do this. This is bad math. These do not cancel. See, you're left with 0.98% per gram. This is just really, really bad math. Anyway, I hope this video was helpful. I hope I didn't offend you or anything like that. I'm just throwing it out there. If you don't believe it, hey, then just ignore it. And no hard feelings. Just don't be mad at me. I just thought I would like to throw out some things for you so you could make your write-ups look perfect. Anyway, hope to talk to you soon. Bye.